Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this learning experience brought to you by ActiveState. My name is Cody, and I'd like to welcome you back to Techstrong Learning. We have an exciting workshop ahead, but before we get things kicked off, we do have just a couple of housekeeping notes I'd like to review with you. First, today's session is being recorded. So if you'd like to rewatch, refollow along, or perhaps share with a friend, you will be receiving an email with a link to access this recording on demand. If you'd like to engage with us, and I'm sure you will, as this is quite an interactive panel that we've got geared for you, the first option to interact with us is that chat tab, which you'll find on the right side of your screen. Nicole has already put a couple of instructions in there for you to help you get started today, but we would also like to hear from everyone. So please let us know from where you are joining us. It looks like we have a global audience, and we'd love to get a feel of where everyone is from. If you have any specific questions, we do want you to direct those to that Q&A tab. Putting your questions in the Q&A tab just helps us keep organized and get to them whenever we can. So if you send them there, we'll have a higher likelihood of addressing it. If you jump to that handouts panel, you'll see there are a couple of resources there for you. A couple of those are going to be integral for following along with this workshop. So if you plan on following along, check those out. Of course, before we close things out today, we are going to be giving away 4 $25 Amazon gift cards. So be sure to stick around for the entirety of our program today. So our topic is building secure and reproducible open source runtimes, subtitle Machine Learning with Pets. And I'm joined today by our panel consisting of Nicole Schwartz, Security Product Manager at ActiveState, Evan Cole, Senior Solutions Engineer at ActiveState, and providing color commentary is our very own Mitchell Ashley, CTO at Techstrong Group and Principal at Techstrong Research. Nicole, Evan, and Mitch, thank you all so much for joining me today. Evan, would you like to go ahead and take it from here?
Sure. Thank you for the introduction, Cody. Super excited to be here today to share with everyone. Before we get going, I want to make sure everyone's set up. If you do want to follow along, there is a Docker image to download. So the steps are: ensure you have Docker installed on your machine and running. Pull the image, and my colleague Nikki has just put that command in the chat, this Docker pull command. And then this is optional but highly encouraged. Make an ActiveState account. You can do so at platform.activestate.com. Now, we're going to be using the Docker image kind of like a pre-baked cake on your favorite live cooking show. So everything you're going to need is going to be there, but you'll also get the chance to bake your own cake, and that is what the ActiveState account is for. So moving on, while you guys do that and download that image, what are we here today to do? What are we trying to address? Well, we have some data and a model relating to machine learning with your favorite furry household creatures. And we have two things that we're trying to accomplish. The first is from the internet. We've found, a really interesting data science experiment in Jupyter Notebook that you can run using open source data analytics solutions in Python. And so we want to, get a Jupyter Notebook set up and get those experiments running. And then also we have a model, a pre-trained TensorFlow model. That's a machine learning model that my colleague has trained, and he has set up a Flask service to operationalize it. And we want to show how we can build a secure runtime environment to support these goals. And when I say runtime, I mean Python, the open source dependencies that are used for both the experimentation and for the TensorFlow Flask service. But, this wouldn't be interesting without a few constraints. And this is where, we would vary from what you would do in the regular open source with regular open source tooling. So we're going to be really focused on ensuring the security and integrity of all the components in your runtime. You can also think of a runtime as a Python virtual environment, if that maps a little bit easier. We want to make sure that this runtime we produce can be shared among the team. So if I want to have Nikki go and run the same runtime to execute these experiments, I want to make sure it works the same on my machine as it would with hers. And maybe I'm on Linux and she's on Windows. We want it to be cross-platform. And the final constraint is that we want to ensure that the runtime that we build is portable enough to integrate into our DevOps pipeline so that when we deploy our Flask TensorFlow model into production, we're able to do so with little friction. And so this is what we're going to address today. So now we're going to move away from this presentation. All the instructions, the code for this tutorial is located in this GitHub repo. Nikki, if you'd be so kind as to post that link in the chat, and we can navigate over to this repo to get started.
Hey, Evan, if I can just jump in, this is Mitch. Also, if folks have questions as you're working along with us, you can watch, but you can also play along at home if you will. Be sure and post those in the chat. You can put them in the public chat, is fine. And Nikki will attempt to help out if we can help you out there, or funnel questions to Evan as we're going. So hope you will play along.
Yeah, that's awesome. Please.
And I just want to tell you a quick story about this little project here. Conveniently, it's passed around person to person within ActiveState. And the nice thing is, it's not that everyone has to, change it up because someone's running Windows and someone's running Linux. It's all in a nice portable environment. So we've linked this GitHub project to our ActiveState projects, and it just goes around to every team member. It's really nice to get up and running, especially for people like me who are into security and interested in this whole ML thing, whereas Evan is really into the ML thing. So we're able to kind of quickly get me up and running on cool stuff like this. So hopefully you all learn a lot and are able to get in real fast to learn.
Yeah, and I think that's what we'll see today is how we go about doing that step by step to really make it real and show kind of how we can combine that security with the ease of use. So to start, we're going to begin by baking that cake we talked about. We're going to go to the ActiveState Platform, which is a system for building these Python environments to support your open source projects. But before we do that, I just want to highlight. So here is the code for this for these two applications. We have the Data Explorer folder, which has our notebook comparing cats and dogs for Jupyter. And we have our TensorFlask service, which is a Python app. And we also have combined our requirements here. And so these are the open source, the third-party, open source libraries that are used to support the first-party code that we saw in those two folders. And what we'll see is that, if you look into these folders, there'll be import statements that actually call for these requirements. And so now we're going to create an environment that will allow you to run your first-party code and contain all those requirements. So let's start. Navigate to platform.activestate.com. If you have this GitHub repo up, you can simply click through and you will be on this landing page here, hopefully. If you are not, make sure you're signed in. And on the projects page, you should see your personal account, your personal organization. And in this organization, in this account, we're going to create a new project. So select new project here. Sorry about that. And we're going to choose Python because we're working in the Python ecosystem. ActiveState supports a few different ecosystems, but today, and many of the machine learning dependencies are Pythonic. We're going to click Linux because we're going to be installing this in a Linux container. And we're going to name our project demo. And once you're done with that, you can click Finish and install Python. And you will see that we have an empty Python project here, an empty Python runtime. So now we got to add those requirements in. So let's go back to our GitHub repo, go to the requirements.txt, copy this entire list into your clipboard. Then we're going to navigate back to our project page. I'll give you a second to do this. And once we're here, we're going to import from file and copy those requirements in. And we see things like Flask for hosting that web server. We have Jupyter for the Jupyter notebook. We have matplotlib for displaying graphs and TensorFlow for the machine learning model. So we're going to import those things. And now something really neat is going to happen. And this is, really specific to ActiveState. So these packages are the things that you will import, the direct dependencies of your first-party code. But the really powerful and also challenging thing about open source is that each component has its own dependencies that are required for it to run. And so although we've only imported 9 direct dependencies, we have 193 indirect dependencies. And our system is able to figure out, based on the versions or version constraints supplied up here, what are the optimal versions, the newest but still compatible versions of the dependencies, not just for Python, but also the system level libraries that are needed and the C libraries that actually go into supporting some of the more complicated machine learning packages. Because the reality is the business logic for TensorFlow is mostly written in C, not Python, with TensorFlow being a developer-friendly wrapper in the Python ecosystem. So this is really powerful observability. And let's click Save Changes and start our build.
For anybody who's been trapped in that, I just want to update this one dependency, and then you lose hours, this just solved that for you. As long as you don't pin everything to give us that leeway, we will figure it out for you.
Been there, done that. I feel your pain.
And, what's really cool is if you do want to change something, everything else will automatically get adjusted so that things are compatible, because, like you guys are saying, incompatible dependencies are a real pain. And, the reason that this is in a project as opposed to, just being a monolithic repo is that some packages have dependencies that conflict with each other. And so you can create multiple projects with specific runtimes that meet the needs of your application. And we're going to see how we support those multiple environments within our tooling. But getting back to this observability, you see that we have the vulnerabilities for all the packages and dependencies. And so from a security perspective, this is really powerful to ensure that you're keeping up to date with your software. And I'm going to just glance over to a project that's been created in one of our paid subscriptions, because you also get additional features related to observability. You're able to download these snazzy PDF reports that give you, full details that you can provide to your security team about your environment. And those are really powerful. We also have the ability to create a software bill of materials because we know all the different subcomponents going into your runtime, we can create a software bill of materials, which is becoming a requirement of being a vendor, a software vendor to the U.S. government. And so that is a really powerful way to comply and manage the massive complexity of open source, because there's so many different components. So going back to our demo project, I want to now highlight in on this build section. What does build mean? Well, most traditional package management systems use pre-built components. And in Python, these are called wheels. And these are pre-compiled binaries that are packaged up into these formats and distributed on the internet. Now, we at ActiveState strongly believe that this is a real flaw in the software supply chain, because there are so many different authors compiling these binaries. You have to trust each author, and you have to trust that each author compiled the binary from the source code that's available online, and it's very hard, nay, impossible to prove that one binary came from one piece of source code. And so you have to trust the author, that they didn't slip anything else in there, and you have to trust that the author had a secure system for actually building these binaries. Say you were going to build Alabaster, and you had a virus on your machine that injected something else into the compiled wheel that varied from the publicly available source code. It was uploaded to PyPy. You consume it with pip. The author might have had the best intentions. You might trust the author. The author could even cryptographically sign that it was them that published this wheel. But if they didn't have good practices when they actually went and built this software, it is a source of supply chain threats. So I'll let that sink in for a second.
Mm-hmm.
We can actually see, instead of taking pre-compiled wheels, we only ingest source code. And what we do is we have a secure system for taking this source code and turning it into a trusted artifact. And what we do to do that is we actually spin up a new machine each time we build an artifact. We disconnect it from the internet. We verify the hash of the code itself. And all the artifacts available, all the code available in our system has went through a vetting process before it actually ends up in our catalog. And so this way, the Python components, the system level libraries, even the C libraries are built from source in a trusted manner. And this is, if you're familiar, maybe you're not, there is a supply chain standard developed by Google and other industry players. And this is what we aim to adhere to. We are the highest level in this framework, SALSA level 3. And this goes back to all these things I've been talking about. So in terms of having a runtime that you can trust, from a security perspective, that is how we accomplish it. The combination of really good open source observability and building from source. And we can also, the other really nice thing about our system is that the projects are all version controlled in a very similar manner to Git. So there's no such thing as not being able to revert to a previous version of your runtime, of your environment. And this really contrasts with pip, because if a artifact is pulled from PyPy and you try to recreate the environment on a new machine and that artifact's missing, well, then you can't reproduce the environment. In our system, because we are cataloging all the source code and all the revisions to the source code, that never happens. So you can be sure that if you are running a first-party project using commit ID 7EB9 on one machine, it will be the exact same runtime as it was on another machine, and it's accessible forever with the ability to go back in time without corrupting your environment.
Evan,
And so
it seems
that
one of the benefits of that too is on projects with multiple people, right? Working in, setting in the same dependencies, the same fixes. You aren't bringing in different sources of wheels, code, whatever it might be, and all of a sudden, not only do you have compatibility issues, but introducing security vulnerabilities, etc. We're all working on the same stuff, evolving the same progress together and in the environment.
Yeah, exactly, Mitch. And actually, I didn't even mention this. Right now, you're building this in your personal organization, but if you put this in a non-personal organization, you can have different team members all have access and all have the ability to edit this. So when you go to your history, you're able to see who made what change, when, and we have full role-based access control to say, hey, maybe some people are just consumers of the environment and some people are editors. This is the runtime that's actually going to be baked into the container you just downloaded, the container image. And this is a publicly available runtime. So right now I have editor access, but if you were to go to this page, you could download this runtime too, as it's publicly available, and share it with your friends. So really powerful, especially for open source projects where you're trying to set up your environment. Let's go back at this point, now that we have our environment, our runtime set up, to our repo, back to the README, and let's take a look at the next step. And the next step is we're going to start, hopefully, it's been enough time that your container image has been downloaded. We're going to spin up the container. Before we do that, I want to show you exactly how I built this container, because it's really cool and it has really a strong it really demonstrates how easy it is to kind of pull runtimes into your DevOps pipeline. So we're just going to explore some of the code here. I have this Docker folder, and if you go into the Docker file, here's what we have. We have the Ubuntu base image. We add a few utilities. You actually don't even need Git. I just wanted to add it in case we wanted to use it. We have, you can use curl or wget. And then what we're doing is we're installing our state tool. And the ActiveState state tool is a command line interface for pulling these environments that you've built on our platform into your local machine, onto your server, into a container like we're doing here. And additionally, if you're using it for development, you can actually forego our web interface entirely and add packages directly to your runtimes from this tool. But in the example of a Docker container, which you might use to deploy a service, all you're doing is, in one line, we are downloading the state tool. The second line, we are installing it and setting up the correct symbolic links. And then to actually download this runtime that we've built, and this is the same runtime that you should have just created, all we do is we state checkout, and we refer to the organization that it lives in, just like the GitHub, and we refer to its name. And so this is what you're going to see when you spin up that Docker container. Really simple to integrate, and it goes anywhere. The other thing I'd be remiss not to mention is, yes, we are doing this in a Linux-based container, but on our Pro and Team and Enterprise tiers, you can set multiple platforms for a single runtime, which means the behavior you can expect when you run this on a Linux machine versus a Windows machine versus potentially an older Windows 7 machine will be consistent. And that's really powerful for collaboration. It allows teams to work on the platform of their choosing, but have a unified experience, and is really something that is very unique to this platform and technology. And so without further ado, we're actually going to spin up that container and start working with the state tool and start using this runtime to achieve those objectives, those goals we set out to do. So open up your terminal or your command prompt on your machine. I'll open mine here. And we are going to copy and paste this command, this docker run command, to launch a container from the image that you downloaded at the start of this webinar or earlier. And so this will both, launch a new container and also expose some ports where we're going to be running our services so we can access them locally. So the first thing is I want you to have that experience of fully baking your cake. So you just made this demo project, and how would we go about, putting this into our new container here? Well, just like we saw in that Docker file, we can use the state checkout command. And so what we can do is we can replace this org with the name of your personal org. So here, mine is FNC demo. It shows a little person next to it.
If you want to copy it easier, the tip I found is look at your URL bar, and it's the chunk of the URL. So for anyone who's trying to copy the thing in our header, sometimes it moves on you. So much easier to just copy it out of the URL bar. Lessons learned.
Exactly, FNC demo. So you go and copy it from the URL right here. And then, just the project is named demo. So my username was FNC demo. I apologize. I know, a bit confusing. And what you're going to see here is it's actually going to securely download the artifacts that you built. We see all the different artifacts starting to download to your machine. And so each one of these dependencies and direct dependencies, these packages will get downloaded. We're not going to wait for this to finish. As I said, we already have a pre-baked cake. We've already downloaded this runtime, but I just wanted to show you how you go from start to finish here. So you can escape that process with Control-C, and that will interrupt the process. And we can use the runtime that we already installed, which should be exactly the same. So to find that, let's take a look what we have here. We have that TensorFlow ML demo project. Let's go into it. Fantastic. So you can change your directory here. And now, if what we see is our Docker file here. We see all our project's code, and we see its ActiveState.yaml file. Now, what is that ActiveState.yaml file? Well, that file is simply, let's go look at it in our repo. It is simply a metadata file that links your your code to your runtime. And so if you actually take a look here, all it is it is a little piece of metadata that says, hey, this project was from the ActiveState SE org, and it was named TensorFlow ML demo, and its commit ID was the most recent commit here, if we take a look. And so that is how we identify our runtime and link it. One thing I forgot to mention is we actually have the option when you run state checkout for the first time, if you paste the GitHub repo into the settings here, it will also bring the code along with it. And that's what we did here. It was linked, so it both downloaded the code and that ActiveState YAML file. What's really neat about this solution in terms of the software development lifecycle is if I were just to git clone this TensorFlow ML demo repo and then have it already contain an ActiveState.yaml, I don't need to know the name of my project on the ActiveState platform. Let's say I'm just a collaborator and Nikki's set this up and I just want to use the runtime. Everything else will be inferred. The runtime itself will be inferred because this ActiveState YAML file exists. And so that is really neat. And because it's configured for whatever platform I'm on, if I'm on Windows or Linux, it's still going to work the same way. So let's kind of test that. The state tool, as we discussed, is a command line utility. You can see it here for pulling packages from the platform, but it also helps us actually run Python code and consume those runtimes that we've built. And so the first thing we can do is we can create a virtual environment in our terminal here. And to do that, what we're going to do is we're going to type, make sure you're in the TensorFlow ML demo folder, state shell. And because it knows you're in that folder with the ActiveState YAML file, it says, great, this project ActiveState SE TensorFlow ML demo has been activated. And doesn't need to download the files again because they are cached on my machine. And what's really cool is if you make an update on the platform, let's say I were to add another package here, I could simply pull in the changes to my environment using the state pull command. So that is really neat. We can try that out here. Nothing is going to happen as expected because we are already on the latest commit. But what this would do is it would update that ActiveState YAML file to show a different commit, and then it would, pull in the cached change, the delta, if there was any new packages. And so that's pretty neat.
Since you run that, in the state shell, the fun thing is if you've got a group of people working together and you're actually bouncing between different versions of Python, maybe because you have an older branch of code and a newer branch of code, you can actually have two virtual environments with state tool in two different versions of Python. And so it's not going to conflict because you're not having to mess up your machine's base version of Python. It's in each one of these little runtimes.
Yeah. And, we can actually see that now. So you see at the start, the prefix of my command here is ActiveState SE /TensorFlow demo. Let's say I run the Python, interpreter, right? I get the Python interpreter that I built, this Python 3.10.11. It was built by ActiveState. It will have only the packages that we added before. So it had Flask, but let's say I also had a 3.10.10, right? Another project. I could use them at the same time, like Nikki said, and have isolation of resources. But the really cool thing is we don't actually need to do this in a interactive way. If you are actually operationalizing an app, how would you deploy your code using one of these runtimes? Well, we're going to see that now. So first, type exit here, or Control D, and then we're going to exit our virtual environment with Control C. Or sorry, we're going to type exit again. There we go. And now we're back in the root container. So the Python will not be that same Python, but we want to use this this virtual environment to run some code. And actually, remember how I said we want to run something in Jupyter Notebook? Well, we actually included Jupyter Notebook within our runtime. So we should be able to, just like we ran the Python executable, run the Jupyter executable, and we want to get that Jupyter executable from this runtime. And so if we go back to our instructions here, what we'll see is this is where we should all be on step 5 now. First, let's get out of this. Let's go into the Data Explorer folder. So we'll cd to Data Explorer just so we have our notebook handy. And then we'll use a command called state exec. And what this will do is it basically allows you to execute commands using your runtime environment, and it figures out, because that ActiveState.yaml metadata file is there, which runtime to use. So this is going to start our Jupyter server. And so let's go ahead and do that. Copy and paste that command in. And you'll see it says operating on project TensorFlow demo. And now this is going to be different for everyone. But what you're going to see is to access this notebook, open this file, or copy and paste one of these URLs. So we're going to copy one of these URLs. This will include a token that will be different for everyone. And we'll go back to our browser here, and we'll actually paste it into our browser. And now you have a Jupyter IDE being served from our runtime locally. And so let's go in and start exploring doing that data science experiment that we talked about earlier with cats versus dogs. And let's try to run that. So we are going to load up our Jupyter notebook. The first thing you see is that we have a bunch of imports, and these are those direct dependencies I was talking about earlier. Your pandas, your NumPy, your Plotly. If you go back, you'll see they're all in this list. And the cool thing is, when you run the Jupyter IDE itself as part of the runtime, the Python kernel, which is also basically a runtime, will contain all these packages. And so it's really convenient to get set up with Jupyter. And it also makes it so that this experiment will be hyper reproducible, both cross-platform and across machines. Because I'm taking the editor, all its configurations, I'm taking the runtime, all its configurations, bundling it up, and it's always reproducible. And so that's really powerful. And so just to demonstrate this actually works, let's actually go in and click this button. It's like the double fast forward to rerun, to restart the server and run the cells from scratch. So you're not seeing cached outputs. And this will take a moment depending on the speed of your machine. And so now what we're going to see is that we have all this really rich data comparing cats and dogs. And I'm not going to go into all of this, but just for example, at the start, first we're describing the data. We're comparing cat versus dog popularity. We have more descriptions of the data, some nice graphs, some really fancy color graphs thanks to Plotly. And honestly,
there's a lot of these out there for free. So if you want to try playing with different ones, there's a lot of free data that's already been mapped out there, and you can grab that and start with it. Because you can see, obviously, a lot of work went into getting all of this correlated together.
And what's really cool is that, like, this itself was a Kaggle project, and we've referenced that in our credits. But there are so many of those projects that you can do just like that. And once you have it in your system, you're free to make changes, right? If I want to try to, maybe I want this in red, or I want to, change, the scale. Maybe I want a log scale. You have that power, and your starting point was accurate. And if you want to collaborate, that's where this becomes really, really powerful. So that's kind of our first objective. We've had this data science experimentation we wanted to do. We generated this report. It all looks good. and it was done using these secure artifacts. So our next step is we're going to shut down that server. So you can also escape it with Control-C and then click yes. We want to shut down the server, and that will kill your session here, and you can exit out of here. Next thing we want to do is we have this machine learning model, the TensorFlask service that we want to run. And this is a pre-trained TensorFlow model built by my colleague with TensorFlow version 1 that can predict different breeds of dog given an image. And so I want to provide a little commentary just on the general AI landscape and what's going on here with this algorithm. But we're going to copy this command, which will go up one directory and then move you to the TensorFlask directory here. What I want you to note is this is a pre-trained model. And, training models is very expensive. I think that in this model, there was like 70,000 images from a public data set of, different dogs and their labels, right? Like if it needs to be labeled. So we'll go into TensorFlask and explore that. We see that here, there's no, 70,000 images of dogs. All we have is the labels themselves and this trained tensor graph. And how big do you think this tensor graph is? Well, interestingly enough, although maybe 70,000 images was many gigabytes or even a terabyte of data, the trained graph is only 5.23 megabytes. And so both
way easier to copy and share around.
Yeah, way easier, exactly. And also very, cheap to actually run. It doesn't take much computation to run a trained model, but it takes a lot to build it. And so, if you've ever studied or looked at, old school compression algorithms, like, how we compress digital music or video, another way to think about the current crop of, deep, machine learning with neural networks is they are really fantastic compression algorithms. And that's just, true with this. It's true with ChatGPT, where we was trained on 500 gigabytes of data. Yet, it's a lot smaller in practice if you actually count the size of all the parameters that it has. So that's just my an interesting insight into this space. And so now we'll go back to, our usually scheduled programming, which is actually getting the service to run. And to do that, let's go back to our instructions here. We're in this folder. And once again, we're going to use that state execute command to run our app with Python 3, with the Python 3 executable. And it's going to do so using the Python 3 executable based on the runtime as specified in our metadata file in that ActiveState.yaml. So let's go and copy this in. And what we're going to see is it starts the TensorFlow model. These warnings are about me not having a GPU. That's okay. TensorFlow can be graceful and actually move to CPU only. And so what we can do now to test this, just to make sure I'm not pulling your chain, is what we're going to do is we're going to actually just look at the pictures we have in this folder. If we go to TensorFlask and we go to Poodle, we see it is indeed a picture of a poodle. And if we go to Pug, we see it is an adorable picture of a pug. And so we can actually access this Flask service locally. And if we just query the service, we can use this command here, copy and paste it into your web browser. And it's going to pass a picture of the poodle and ask the model to make a prediction. And so we have 99% chance that it's a poodle. That's correct. And then we have the picture of the pug. Let's see if it can tell the difference. Oh, I think I added a period there.
You added some stuff at the end, yeah.
Yeah, my copy game is not on point, but if we add the picture of the pug here correctly, it is very certain that this is indeed a pug. And the cool thing about
pugs are easier to tell apart than poodles?
Well, that's an interesting one. I'm curious why it's so certain. I don't think models should ever be that certain. But what's really cool is if you were to operationalize this in your pipeline, you would simply add this state execute command at the end of your Docker file so that when your Docker image starts up, it runs this command. And then you'd have, in like 5 commands, an image that would run this service. And so really, really nice integration into your DevOps pipeline. And so that's really the end of the interactive section of this tutorial. I just want to go and summarize kind of what we saw, some of the takeaways here. Let me just go and stop sharing my screen here and go back to the slides. So here are some of those takeaways, and they really relate to the constraints that we talked about earlier. The first thing, open source observability is really important. Knowing what goes into your open source runtime or environment really allows you to have better security and better functionality. Functionality in that we can figure out what the system level libraries are and actually vendor them as part of your runtime. So there's no chance you don't have something. This helps make the environment work across multiple machines. Security in that it allows us to build everything from source, component by component, and see all the vulnerabilities in our runtime. So open source observability, that's one takeaway. By bundling everything together in one runtime, we made this really portable and reproducible. And we could do it. Today, we showed it off in a Docker container so everyone could be on the same page. But you can go and if you upgrade your account, try it out. Windows versus Linux, it should work exactly the same. You get the same IDE and the same runtime environment. So that's the other powerful part of this. There's my comment about, ML models are really cool because they're like really good compression systems, something that we can never actually manually write rules to create. And they're able to take huge amounts of data and compress information around them. And then, with a lightweight command line tool, you have the flexibility to kind of integrate these features wherever you need to, be that Azure DevOps pipelines or on a local machine, wherever you need it. Because the state tool is lightweight and cross-platform, you can integrate this technology into your stack. And so with that, I will pass it over to QA. I hope we have some juicy questions.
Yeah, I've got some here. Yeah, got a few sent in, Evan. One of the questions is, can you describe again sort of what's happening in the ActiveState session, in the web session online, what's happening in the local runtime environment on your computer, and how do you sync those up to date? Let's say a new a version of one of the libraries you're using, packages that you're using gets updated. How does that happen so you're using the latest stuff?
Yeah, that's awesome. So there's a few ways that happen. So first of all, let's start with the difference between your what's happening online versus your local machine. Both the website and the state tool are interfaces for our platform, which does live in a SaaS environment. And there, you can add packages, remove packages, configure your projects. In terms of keeping things up to date, our auto mode assists with that. So when you go and use auto mode, it's able to select a new set of dependencies that are as up to date as possible. You can also manually update things. And how does that relate back to your local machine? Well, we have that state tool with a specific commit ID. what happens is when you make a change and save it, it generates a new commit ID, just like Git, and you have the ability to pull in that version to update your local commit, which will, with that state pull command, then bring in those new packages.
Great. So it all tied back to that state ID then. You'll know you're using the most recent. Good. Another question that came through was, talk about if I need to kind of go back and work on a prior version of my application. Maybe I'm using a, different older version of Python or one of the packages or something. How do you do that? Do you refer back then to the state ID for that environment, or is there a way that you can get to that point?
That's a great question. So the cool thing is, you can, because the commit ID of your environment is, checked into your GitHub repository, as you make different Git commits, they'll have different commit IDs on the ActiveState platform. So let's say you were to check out an older version of your project at a previous commit, the environment commit, the ActiveState commit, will also go back. So then when you go to run your code with the state shell command or the state execute command, you're actually going to be using that older environment, which is, super, super nice.
So the fact that they're tied together in your repository version history. Okay, interesting.
And the ActiveState platform can branch, much like you can do with your CI/CD tools. So if you want to mirror the branching within ActiveState to your Git repo, you can absolutely do that.
Great. And that actually brings up a question I had is thinking in a DevOps workflow in a CI/CD environment, how would this tie into, if you were using Circle CI or Jenkins or something else as your kind of CI/CD platform? How does this fit into that workflow, that tool chain?
Nikki, you want to take this one, or I can take it?
I was distracted by the QA tab.
All right.
Can you say it one more time?
Yeah.
Okay.
So the state tool can actually be, built. You can actually run commands with the state tool in these different systems. So, Circle CI, we actually use it internally, is able to run state commands. And in that way, you can directly integrate the same things you were seeing into those other CI/CD systems. So anything that can execute a bash command can really utilize the state tool, which is very powerful.
That's one of the things I was noticing in your documentation is fantastic, by the way. Then in the flow there is the fact that you have those URLs, or here's the state ID, or the things that you can automate, right? Because those things can be written out to a configuration file or pulled from the YAML or whatever source that they're in, and make that part of your automated workflow, which I think all of us are trying to do, right? To get more done quicker, faster, and smaller chunks, the whole DevOps idea, right?
Absolutely.
I'd love to have you, I'm sorry, do you want to add more, Nicole?
Yeah, there's a question I can't answer over in Q&A. Do we support Kubeflow on Vertex AI? I have not seen that one, but I'm not keeping up with the ML stuff since I'm keeping up with like the SASA and SBOM stuff. That does not sound familiar to me.
I think we do have some customers who do use that actually. I can't verify it myself, but generally any system that allows you to use a custom Python environment basically is interoperable. So yes, there are certain services that lock that Python environment and say you can only use what we have, and then there could be issues. But generally, if it's extensible, it does generally work with the state tool, or alternatively, we offer an ActiveState artifact repository service that essentially acts as a pip compliant artifact repository, which you can use with the pip tool as a secondary, foreign repository. So instead of PyPy, you point it at ActiveState, and that's another way. If the base Python is locked, you can extend it artifact by artifact.
That's something too. Participant 70 asked that question. We can verify that after the workshop and get back to you directly. So we'll do our best to answer that question for you about Kubeflow. Were there any other questions? We are right in 5 minutes before the end of our time. And we want to make sure we give away those gift cards. I know Cody is like chomping at the bit to come back on and give those out. So we have a few more minutes. There was another question in there, Nicole, about is this classified as transfer learning? I don't know. I don't understand that question. Maybe you do.
I have not heard of that particular one. I've heard of like PMP credits and other things. So Unfortunately, I don't know.
Okay. I'll ask Cody to look into that and see if that's coming from participant 502. We'll see what we can find out for you and hopefully get you some credit if that's possible for it. We're just about out of time before I hand it back over to Cody. Evan, Nicole, each kind of parting thought as we wrap up here. We have a 30-second parting thought for folks.
No more dependency hell. That's my parting thought.
I guess, lots of folks don't want to use open source ML because of security risks. And, if you were in an organization like that, you're really missing out on, some of the most complex and interesting software that's available today that could really only be generated by the open source community, a lot of it. So this is a solution that really you can bring to your, oversight board and say, hey, we can have the best of both worlds. And so that's kind of what excites me about this, especially for enterprise.
I love just the cognitive load you can hand off to ActiveState, keeping this up to date and synchronized, and vulnerabilities being taken care of and followed and updated. Man, that's now I can focus on the work I want to get done, which is ultimately, and especially in a team environment. Maybe that's something. Love to see more. Maybe another session on that. Really excited to see what a team, how they can leverage this. So. Great to both of you, Evan, Nicole. You were so knowledgeable, and I think you did a really good job. Really nice way of presenting a really clear path of how to do this, and it's all there. And folks can go do this on their own. Watch the video from this. Everybody will get an email with a recording from today's workshop. So, thank you for all the folks. A lot of folks attending today and playing along at home, as we like to say. So. On behalf of the ActiveState team and also the Techstrong group team here, thanks to both of you and our audience participants. Cody, if you want to come back on, and I think you have some gift cards or something you're looking to hand out.
I sure do. Thank you for that, Mitch. And Nicole, Evan, thank you both for joining us as well. That was an awesome workshop. And while I wasn't following along in spirit, I was able to follow along with everything. So thank you all so much for that. I would like to remind our audience today that this session was recorded. You will be receiving an email with a link to access this recording on demand, or of course you can find it on both the DevOps website and the Security Boulevard website. So it's devops.com/webinars or securityboulevard.com/webinars. You'll find it living on both. It's twice as easy to find. The 4 winners of our $25 Amazon gift card drawing are Aaron B., Vince S., Luther M., and Stephen I. So to our 4 winners, congratulations. Keep an eye on your inbox to claim that gift card. It should make its way to you in the next 48 hours. If you don't happen to see that email, check your spam folder just in case it gets filtered out. I'd like to thank ActiveState for sponsoring this program today, and to everyone who joined us, who participated in our chat, or even followed along with this workshop. Thank you so much for being here. We really appreciate your time, and we want to ask for just one more moment. There will be a survey that pops up as soon as we close out, and we would love to hear your thoughts, whether it's about this workshop you just participated in, or if you have recommendations for an upcoming program. Please do let us know. We want all of the feedback. Either way, we do hope to see everyone at a future Techstrong learning experience. Have a great rest of your day. And Evan, Nicole, Mitch, thank you all for being here.
Thank you.
Thank you.